Welcome once again. We are continuing from where we left off, or we are getting into new content that we want to work with. So far we've done functions, we've done files, we've done pointers, we've done operators, control statements, etc. So most of what we have done still works in the new projects that we'll be working with. So I'm hoping that as we work with our content, we'll be able to learn, we'll be able to do different items that we can be able to use in our learning. So let's get into the next thing that we need to learn in terms of our code. We will also just get different items that we need to build our project. So let's start with the first lesson and we proceed. So now we want to actually work with more on our data types. The data types pretty much works as follows. I'll just put some notes as we go along. Let me actually put a notepad and explain some of these things as we go along. So we're saying we want to work with our data types, and our data types pretty much work as usual. We've got primary data types. These are data types that pretty much store a single value. So single value elements. At the same time, we're saying outside of single value elements, they pretty much represent one block of data in memory. Also at the same time, they have a fixed size in memory. That's pretty much what we are saying about our primary data types. Then at the second time, or the second type of data types are the secondary data types. This simply means now they've got more than one element. Okay, so far we've actually worked with an array, whereby we are saying an array has a data type sorry about that, it's got a data type, it's got a size, it's got the elements. Okay, so in other words, we're getting more than one element. Also now, this then means that this affects memory, because we won't really have a fixed size, right? So this is also due to non-fixed size. Okay. At the same time, we're also saying with our secondary data types, we can now be able to add more data, okay, with our secondary data types. That's pretty much what it means. So let me save this. I think the easiest would be to save it in all the content that I've been working with. Yes, it's for code. So I'll save it in notes. Okay, I'll save it there. So we want to work with our secondary data types, and hopefully we can be able to have more than just one, and we see how these work. So the next data type that we want to actually work with is called a structure. So a structure, we pretty much work with the keyword struct, and then we put the name of the structure. We can then call it data. Forgot the T. Okay, and then it's got a semicolon. That's how a structure works. So it's struct data, and then it's got a semicolon. And this is what we then refer to as our structure. At the same time, we can also be able to do two ways of actually working with our structure. We can have it this way and then define our structure, or we can actually give it a value that we actually want to call it at the next stage. So maybe I'll do the two examples and you see how it works. So with our structure, we define our variables as we need to use them. So for example, we can say int, and then we say age is the first element we want to work with. Then we've got character, and then we want name. And the name has to be an array so that we get more than one value. So we can put it as maybe 10 so that we get our name. At the same time now, this is structure definition. Like that. These then become our variables. At the same time now, we're then saying we want to be able to call data. So we come to our main function, we then say struct data, and then we need a name that defines what data is. So we can call it n, right? This then defines what our data is. At the same time now, we then now need to use our structure in our main function. So we simply put a printf. Our printf gives us the following, right? Enter a valid age. Okay. We put a new line, and then we put a scanf to be able to get what our structure is doing. %d, and we want to get the value in our structure. So as you remember, when we're working with variables, we then need to simply put a variable. In this case, we didn't define a variable as such, or conventionally the way we define our variables. So to be able to actually get a variable without variables, we actually want to work with our structure and then get the contents within the structure. So what we do is, after putting our ampersand, we put an n, we put a period. The period now then links us to two things. We're saying n links us to line 13 where it says data space n. So n becomes what we are referring to as our structure. And then the period now takes us into the structure and gives us the value that we want to work with. So in this particular case, we want age. I select age, we are good to go. At the same time, we can also do the same thing for the next value, which is our name. So we want to enter a valid name. Okay, put a question mark, and then we proceed. Scan if like that, and then we want to get percentage s, and we want to get our n dot name like that. So this then means we've actually entered the values that we want. We can actually run it and see how this works. Hopefully we've got no errors. Okay, so now it's telling us enter a valid age, 34, enter a valid name, Hope. Okay, so it accepts the content that we actually want to work with. So in other words, this is how we actually work with our structure. I'll not give us the option to be able to view, because we already know how to view our content. The other alternative to actually working with our structures, we can actually do our structure in this particular manner. We can call it a struct in that way, and then we don't put a value like we did there where we've got data. We can actually then add an extra value, and we then say what we want to put our structure as. So we want count, okay, or rather let's call it counter, because count is similar to something that we've got already in C. So let's say we want it to be counter, and counter contains just one variable, which is num. Okay, this is what we want to work with within our sorry, we don't want it to be counter. Counter is what we will then be able to use. Okay, that's what we want. Let's actually remove that, but we want to put counter there. Okay, so in other words, we've still got our structure, and we've now got counter as our structure value. Okay, so what it then means now is we are saying instead of declaring this on line 15, struct data n, we can actually now be able to refer to our counter and get a value. So how can we see how this works? We simply say counter, okay, dot num, like that, equals a specific value. We can then give it 9. So in other words, we're then saying if we write our structure in the new way, like we've got on line 9 to line 11, we can now be able to bypass what we did in line 15. So in other words, we've got our structure linked or called in a slightly different manner. So that is how we can also work with our structures. I decided to just put them hand in hand so that we can see what this gives us. And as you know, we simply put our printf, and we can be able to view what this gives us. So we can say the first thing is age equals %d, and the next thing is name equals %s, and then the next thing is our counter. So the last thing is counter equals %d. We put a new line, and then we put a comma. So it's it's n dot age, and then n dot name, and then counter dot num, like that, so that if we run it, we'll be able to actually view the content within our values. Okay, like that. I don't know why it didn't work on the first one. So our age is 4, our name, it actually just took 5. I think it's because, okay, that would definitely need to fix in the next project, but at least we have our use. Rather, we need to fix in terms of the logic, because it still gives us what we are looking for, and this is how our structures